Hello, we're the Michelin Auto Collapse Drums Senior Design Team for spring of 2022. We have Taylor Hull, the PL, Joseph Burgess, Michael DeRusso, Zach Carvo, Noah Starnes, and Ryan Prussia. We're supported by Professor John McAlpine and our industry supporter Ryan Brown at Michelin, and we thank both of them for their support throughout the semester. Michelin approached the senior design team to create an automatically collapsing drum for their 15-inch inner diameter tires. Design requirements are as follows. In the expanded form, I'd have a 15-inch inner diameter and an 18¼ inch outer diameter. When the collapsing motion is performed, the diameter would be 13.5 inches or less. There would be an undercut angle of 55 degrees, and the drum itself will have a smooth outer surface with rounded edges. The developed design has three subsystems. We have a plate assembly, a lead screw assembly, and the flange design. The drum will collapse through a radial motion that is driven by the lead screw. The flange is attached both to the lead screw and the underside of the plates and the pivot point. The width will be decreased by the lead screw, and the rotary motion will be performed by the planetary gear system as well as the motion of the flanges. Here we have the lead screw design. It will utilize a 2¼ inch diameter bidirectional lead screw, so that's going to allow for movement in two directions. It is also going to utilize a planetary gear set, which will drive the rotational collapse of the drum. There will also be two sleeves on the shaft. One is a floating rotating sleeve, and there'll be a fixed sleeve. Next, we have the flange design, which can be seen in Figure 4. It is a multiple set double shear design. It is going to support the plates during the width decrease, as well as drive the rotating collapsing motion. The main support flange was increased in width to withstand forces. One set of flanges is going to be attached to the stationary sleeve on the lead screw, and the other set of flanges will be attached to the rotating sleeve. Connections of these flanges go to the underside of the plates as well as to the pivot point. Finally, we have the plate design, which is made of 6 plates to create the full circumference of the drum. There are two sizes of these plate assemblies, one short and one long. This was made to ease the collapsing motion. In each of these plates consists of 3 smaller plates. There are 2 outer sections that create the shoulder, as well as a middle plate. All these plates are connected to each other using a rack and pinion system, and this is going to ensure even lateral motion between the plates, which can be seen in Figure 5 on the left. Figure 5 on the right showcases the pivot point that aids the collapsing motion.